All right. Hey guys, I'm here with Amogh, who worked on a protocol called Moby. Do you want to explain the protocol, the design of the application, what you're presenting here at PETS?
Sure. So Moby is a blackout-resistant anonymity tool for mobile devices. Essentially, it's a protocol for people to run on their phones, which uses the internet to establish trust between a couple of users. So people you want to talk to, you do this protocol with them. And when the blackout happens, so essentially a blackout is where someone shuts down the internet. And so when the blackout happens, you use this information that you established before the blackout to actually communicate with people. And what it uses is essentially an ad hoc network. So people just peer-to-peer send messages to each other as they walk around a particular region. And you hope that the messages get through to the destination using this ad hoc network.
Yeah. And you said in the talk that you use epidemic routing. Can you kind of explain or give an overview of how that routing works? I know you said as you walk around, but is there...
Yeah. So epidemic routing is like a store and forward principle. So essentially, when you perform message exchanges with people that you come in contact with. That's the first part of it. And what you hope is that they hold your messages and then go and pass them on to other people. So basically, you send messages to everyone you can send them to. And they also do the same, where they send messages to everyone they can pass it on to. And I mean, of course, sizes of how much storage people have is limited. So you end up having, so each node in such a system would have to decide how many messages they want to hold and based on what they want to drop these messages. And that's about it. So you hold messages and you try to go and spread the message.
I understand also that you have a client implementation or a research client implementation. Can you explain the technology that you're using for epidemic routing then? I've heard Bluetooth and Wi-Fi direct, so what's kind of the range of that, and when do you decide to use Wi-Fi direct versus Bluetooth?
So the Wi-Fi direct and Bluetooth combination is an outcome of how the Android system works. To establish a Bluetooth connection between two phones, you need the MAC address of the other device. And there's no way of just emitting the MAC address with pure Bluetooth because you don't know what to connect to get this message that they're sending. So we use Wi-Fi direct for that. So essentially the Wi-Fi direct one is you rename your Wi-Fi direct name to Moby followed by the MAC address.
Okay.
Yeah, so that's kind of the giveaway. So when people see, they keep listening for Wi-Fi direct connections, and when they see it in a particular format and the MAC address, they just take the MAC address and establish a Bluetooth connection with it, which then lets you do the message exchange over that connection.
That makes sense. And what range is this? Is this depending on what the device is, I suppose? Is it 15 to 20 meters or?
Honestly, open air, no obstruction. It's supposed to be 100 meters.
Okay.
Yeah, but that's ideal case.
Yeah.
So no obstruction in open air.
Yeah.
Things change a lot based on where you are. Buildings that are wood, again, it's great. It's almost like having no obstruction.
Yeah.
But things that are concrete, you kind of get destroyed. So it's as good as how well your Bluetooth headphones work.
Yeah.
Which you can walk around and figure that out for a place.
Have you also thought about iOS integration? I know that they perhaps have some different settings, or you think this would apply using the Wi-Fi direct stuff? Would that apply just as equally to iOS?
So we never made an iOS app for it. We just made an Android app, and it was a proof of concept. So the main thing with the study was trying to see if this combination of techniques would be able to produce some good things in a region.
Yeah.
And not necessarily on coming up with an actual tool for it. So back then we used to have other postdoc researchers as well on this project. And they were embedded in some, human rights organizations. The person I'm speaking of used to work with the, MSF, the Doctors Without Borders.
Yeah.
And the idea there and back then was to get some organization like that to actually provide, support for making an app like this.
Yeah. Okay.
But yeah, we would need something like that because it's not really very easy to maintain something like this.
Yeah.
And when you get to that phase in the project, I guess you can think about iOS. But honestly, practically, I don't know how you would do it. I don't have experience with iOS apps. So
Is there any issues? I mean, because the presumably the application would be running in the background on your phone, like with the Wi-Fi direct enabled and then also Bluetooth enabled. Was there any thought about battery considerations, like that it would maybe drain the user's battery faster, or do you like turn it on every 15 minutes and check whether there are people in range, or is it always on?
So it's always on in the proof of concept, and it's actually not consuming a lot of power because we did measurements. So we got this BATR device. It's another research project device which you physically plug in on the battery, and you kind of have to run a custom build of Android. And when you put those two together, you get extremely precise battery measurements for operations. And what we saw was that PSICA, so the private side intersection stuff, was the expensive operation. But just doing message exchanges and the Bluetooth stuff was nothing at all. So,
Can you explain where you use the private side intersection cryptography, like why that's used in the application?
So one of the ideas for establishing trust. So clients that use Moby initially during the internet have to do this trust building protocol with all the friends that they would want to talk to. And one of the ideas there was to figure out a way in which you can trust your friend, or trust someone who's in your contact list. Because it's on your contact list and not necessarily some friend of yours. So one of the way was to, let's think about how many times I talk to them. So if I talk to them extremely frequently, let's say in the last 30 days we've spoken 10 times, then that's a pretty decent metric to say that they can be trusted.
Yeah.
So that was one signal we used. But another thing could be that you just don't talk to them a lot, but you kind of are in the same social circles, right? So you kind of trust other people who they also trust.
Yeah.
So there is a notion of you can probably trust that person too.
Like 2 layers deep.
Yeah. So to capture that, we did the private side intersection stuff.
Okay.
So even though you do that, you kind of don't want to expose what your contact list is. So even if it's between the two of us, I don't want to give you all my contacts to try to come up with how many contacts do we actually share.
Yeah.
And private side intersection gives you a very nice way of exposing that without exposing your actual contact list.
So it lets us work out the matches between our lists without exposing the entire.
Just the cardinality. So private side intersection does the matches, so you can compute the intersection. But there's a private side intersection cardinality protocol, which only gives you the size of the intersection, not even what's in the intersection.
Right. Okay. So that would tell us, for example, that we have 10 contacts in common, but not necessarily the contacts.
Which contacts?
Yeah. Okay.
Yeah.
And where do you see this research going in the future? Did you have future work that you wanted to investigate in this, or do you think that it's out there, it's published, you're waiting for other people to work on it, or?
So, like I was saying, it's I would love to see this deployed. The good thing is that there are other projects. So Briar is one, and FireChat is another, which has been used in the past.
Yeah.
And those are companies now which are established. So what I was aiming to do with this was that someone like that who's actually working in this field already would pick this up and then implement this into their systems. Yeah. So all the ones who are doing any kind of ad hoc communications, they could take some findings from this. And there's also a lot of future work. So the trust establishment, the better that is, the better the system works. So if you could come up with better ways in knowing who to trust in a region and better protocols over the internet for it, then that would be even nicer to do.
Have you spoken to any of those companies yet, or application developers like Briar, or?
No. I have met the person once, but this was actually before I was working on this project.
Okay.
So I think so. This kind of went to the back burner because I also pivoted in my PhD after this project.
Yeah.
So I'm not working in a related field at the moment.
Yeah.
Like I'm doing more data leakage of Android apps and studying like apps these days more than I'm doing anonymous communications.
Yeah.
There is one problem in the field, which is the last thing that needs to be solved. And if people do solve that, then things would be nice. So metadata private communications over the internet, which are practical. So I say which are practical because there are many systems today, but no one is deploying this. So essentially, if you could get Signal to somehow be totally metadata private, then congratulations, like anonymous communications is done, at least for like messaging friends.
Yeah.
So,
and if anyone hears this and wants to reach out to you, how would they do that?
Email is the best.
Yeah.
You can find me. I guess not if you Google my name, but yeah, if you Google my handle, like I'm the same username on like everything that I have.
And what's your handle?
Amogh BL1.
Okay, cool.
So that's the handle. But yeah, you can search for Amogh Pradeep Northeastern or something like that, and it should pop up.
And any shout outs you want to do, like to co-authors or people that you helped you on the paper, or?
My advisor was a great help for this as well.
Yeah.
David Schaffness. Brian Ford helped out a bunch in the early days as well, with a lot of reviews. And the other authors were the ones who started this project actually. So Antoine and Stevens, they're two other authors who started it. And Ryan is a person who joined Northeastern after and who was really helpful with the trust establishment stuff. And lastly, we have Hira, who helped with some of the simulation code in the early days as well.
Yeah.
Yeah.
All right, cool.